Hello everyone, welcome back. Like I said in the last video, we took a bit more time to complete the classification of data. Like I said, it was necessary for us to understand so that we can complete the remaining part easily. So what we studied in the last video was actually the chapter 1 from the textbook. So if you have seen the syllabus, you can see that it is divided into chapter 1, chapter 2 and chapter 3. So this entire thing in the whiteboard now you can see is complete chapter 2. Okay. So here, as you can see, each heading in the red pen is nothing but a certain topic in the textbook. So now we will be covering it very fast, not just sometimes if you cover fast, like it's not that valuable. No, it's not like that. I will explain everything what is required. Just take notes if you want in the middle. Anyways, the notes which I made will be provided in the description with proper editing and all. So let's start without wasting time. Or data characteristics. So you have big data, right? Big data characteristics. What is the characteristics of this big data? There are three C's, remember: composition, condition, context. Let us understand what is composition, condition, context. We'll take an example of buying a second-hand vehicle, used vehicle. The first thing is composition. What is the what it is made of, this second-hand vehicle? So you see like what type of bike it is, scooty, gear or gearless. What's the engine capacity? You see that cc 150cc 200cc motor and all. What year model it is? It is before 2000 or after 2000, latest model, like that. It is single owner or multiple, like it is like only one owner, in the sense what, so it was sold to only one guy. If it is multiple on, like I sold to a person, A sold to B, B sold to C, now you're the person D. So you're buying it from C, but it was also bought from different people. So it's like very, it's not second hand, it's like four hands or five hand. Just kidding. Okay, so that is condition. What is the condition of the second hand vehicle which you are going to buy? Does it need repairs? Engine is in good shape or not? And all the tires are worn out or not? Is it good or not? Chain is good or not? Seat is good or not? This is the condition. Then you have context. Where did it come from? Why is the owner selling? What's the reason for him to sell? Where was it used? How was it maintained? What's the service history? So this is just an example. Now we will see actual information how we talk in compared to big data. So composition, structure of data. Where did the data come from? So we have data, right? From where did it come? Did it come from any social media platform, or from any bank, or from a market, or from any reliable source, like that? Okay, so how detailed it is, what's the value, like what to say, quality of data. Then what is the types of data, whether it is only text or it is images or videos. So that all comes under composition. What is the nature of this composition? Like, is it static, that is not stored, or real time streaming live data? So there are, see, if you have to talk about data, so if like old data, it's already stored. For example, let us talk about video itself. If you're seeing a premiere, okay, so for example, a video is already recorded and now you're watching it in YouTube. So it's already stored data. If I'm going live, that is real time data. So that's the difference. That is the nature of the data. It is whether it is static, in the sense what already stored, or real time data. Then condition, state of data. So ready to use. What do you mean by ready to use? Use in the sense for usage of data. Why we are using this big data? Why we are analyzing this, so that we can get meaningful insights and use them for improving the existing data. Does it need cleaning? For example, does it have noise, or some place unnecessary data is there? Should it be required or removed? It's like that. Missing values, duplicate values. Then enhancement needed. Do we need to enhance this data, enrich it with additional information, etc. So that is the condition of the data. Then we have to talk about the context. Context is nothing but meaning of the data. Where was the data generated? In a mobile phone, a social media platform, any computer, etc. like that. Why was the data created? Why was this data created? Then how sensitive is this data? Then what events triggered this? It's all different differences. That is the context. All this you have to understand. Simple, right? The points which I gave in under each will be given in notes, so you don't have to worry. It's just an understanding. Once you understand, then you read. It's very easy. Then we'll move for evolution of big data. So see, you have timelines over here: 1970s, 80s to 90s, then 2000 to present. In 1970s, the way we used to deal with data is nothing but in mainframes. So we also call the mainframe eras, where the data types are like primitive and structured data. So till here you have structured data. So it's just nothing but only structured data. No introduction to semi-structured or unstructured data. Use case of this mainframes era nothing but basic data storage like payroll, inventory, etc. Example, if you have a grandparent, then their passbook, okay? So that's an example. Then 1980s to 1990s, the database revolution. In this revolution, the SQL was, invented. The Oracle or SQL Server born. Data type complex but still structured data. Then use case data intensive application like banking and that airports and all for airlines. Example nothing but ATM transaction and booking flight tickets, etc. 2000 beyond. This is the big data explosion where massive data was generated with the help of not with the help of due to www, etc., where we introduced like Hadoop, etc., such things were introduced. Now all types of data were here structured, here primitive and structured, complex and here all structured, unstructured and semi-structured data. Then we have what triggered this data, that is World Wide Web or IoTs, sensors, devices, collection of data, etc. Example, Facebook, mobile phone, YouTube, mobile phone like calling and all, browser history, all the data and all. What changed everything? So see, 1970s, in this timeline, what changed? www, like everyone online generating, data 24/7. So though if we are sleeping here, but other side of the world is awake, right? So they are using the mobile phone, www, internet. So data is generated 24/7. IoTs, smart devices everywhere, like Alexa or any sensors, etc., like that. So they all generate devices data to social media. Billions of people posting, which means billions of data. If 1 million phones are there, then 1 million data. 5 million phones, 5 million data is being generated. Then section 3 is nothing but definition of big data. So so far we understood what is big data, but how do we define it? So you have to remember the three V's, first three V's, important, okay? All are important, but these three. So big data is nothing but high volume, high velocity, high variety of data, which are demanded for cost effective, innovative form of information processing for enhanced insight and decision making. So what do you mean by high volume, high velocity and high variety? So massive amount of data arriving super fast, which comes super fast and in many different forms. Cost effective, innovative forms and information processing. So in this, what is the cost effectiveness of the data? We need new technologies and tools to handle this upcoming big data. In the previous time, you had this servers, room size computers and all. But in latest technology, you have different technologies like Hadoop, etc. and all. Old way traditional only, vertical data was being, upgraded vertically, like one level to. But here we have horizontal where multiple servers can be added, etc. Okay, now we have Hadoop, horizontal scaling, etc. In part 3, enhance insights and decision making. Turning the raw data into useful information. That useful information is used to make smart decisions, and this smart decisions lead to business value. Okay, so that's what we do. Enhance insight and decision making. So just an example, you have to remember 3 V's: cost effective, innovative form of, it's off, okay, for this. That's it. Then we have why big data. Oh, sorry, this is the last part, right? We have to move to this challenges of big data. So we have 8 challenges of big data. Let me come here. So each type of challenge, you have different challenges for everything. So this is capture. Capture is about how to collect this data. Okay, so it is a challenge, right? One second. So capture is nothing but how to collect this big data, capturing tweets during World Cup match. So millions of people are tweeting. How to capture it, and meaningful correct data is captured and etc. Challenge nothing but real time ingestion without data loss. Storage, where to store this petabytes. If you talk about hierarchy of storage, you have KB, kilobytes, megabytes, gigabytes. You have terabytes, petabytes, exabyte, zettabyte, and yottabyte. So many, that's all that hierarchy. How do you store it? So the main challenge here is nothing but how to store, like cloud storage and all. So cost effective and scalable storage. You need proper way of storing and less way also. So you have this model solution like Amazon, a cloud storage service and other things like that. Then you have this is curation. Curation is nothing but data cleaning. The data which we have acquired, is it clean or not? So is it ready to use or not? Does it require any cleaning or anything like that? Metadata is messy, so right, many things are there, sometimes wrong spellings and all. So the main challenge here is standardize and clean before analysis. In the sense, what before you analyze data, it should be standardized and clean. Then you have search. You have this billions of big data, right? How do you search something if you want to search something? That is also a problem. Finding relevant data in petabytes. Challenge nothing but fast indexing and retrieval. So though it is big, you have to find it fast. Fast indexing nothing but if you want, for example, in a PDF, if you search for something, a word, so it immediately shows, right, how many search results, matching results are found, and you can simply navigate. That is fast indexing. Analysis. In traditional tools and too slow for big data. So analysis is nothing but what if you have to analyze the data. So traditional tools are too slow. So we have to introduce new tools and all. So real time analysis on massive data sets is important. That is a challenge. Okay. So how do you analyze it altogether? So real data will be coming and going. So frequently new data is keep generating, and you have to analyze it. So that's also a challenge over here. Transfer of data. Transfer in the sense what sharing, the delivering, or moving the data from one physical place to another, or from one software place to another. So it's also very difficult, so petabytes of data. So challenge is nothing but literally there are truck load full of hard drives being moved, transported. So that much big data there. So the challenge is how to physical shipping of this data. How do you do it? Visualization is nothing but gaining meaningful insights in complete data. How do you display insights from billions of records? So the challenge is interactive, meaningful visualization. So among all the data, I don't need this junk data. I just need the meaningful data. So how will you filter it and display me? That's the main thing. Privacy violation is nothing but this billions of data, massive data contains personal records, privacy data of many users which shouldn't be leaked. For example, if bank people have maintained the records of bank users, so that data should be kept very privately, and so that data cannot be leaked, right? So it's a problem. Privacy data, sometimes anything about a person which he wants to keep private, doesn't want to share anyone, so it has to be kept like that. But due to some problems, like if servers leak the data, that will be a big challenge. So challenge here is comply with GDPR, data protection laws. Then we have to talk about 5 V's of big data. Volume, the enormous size of the data. Volume stands for the how much, how vast or how big is the data it can be stored. You have to talk about the storage. It can be in large volume like MB, GB, PB, ZB, zeta and all. So you have to talk. Just mention all the data size ladders, okay, one by one. Then you have this velocity. So you have to talk about the real world examples also. How the big data is generated, how it from where the data has come, how you have to store and all. So that comes under volume. I won't be explain much. I just explained you from the tips so that you understand it and you can easily write in your own words. If you once see the notes, you'll understand. Velocity, how fast the data is generated. You have real time data. Millions of people are using their mobile phones and computer servers. So everything is generating data. So how fast the data is being generated. And you have to talk about the speed evolution. Like first it was batch processing, and now at the now real time processing. Previously you couldn't process it as a real time data. You had to divide into batch and do so many things. Then periodic processing. Now at the latest time we are doing real time processing. So you have to talk about what, how fast the data is being processed, how fast it is generated, and how fast it is being processed. Then variety, different types of data. You simply have to talk about structured, unstructured, and semi-structured data. I won't be saying much. We'll move to veracity and value. So value is nothing but validity also. Veracity is nothing but the meaningfulness of the data. How clean, how good, how meaningful the data is, how it can be used. Veracity is nothing but, or sorry, value or validity is nothing but accuracy and correctness of data. When you talk about veracity, you have biases in the data, noises in the data, and some abnormalities and fake data. That shouldn't be there. So that veracity is nothing but removing such things, making it trustworthy. Value and validity is nothing but accuracy and correctness of the data which we are using. Why big data? So here we have a ladder type of thing, a diagram in textbook. It's just this part of content in the textbook. Like if there is more data, then you have more accurate analysis. Okay, more data, more accurate analysis. I'll just draw a small this. More data gives us more accurate analysis. If you have more accurate analysis, then you have more confidence in decisions. Good decisions. I can make good decisions. If you make good decision, typically it will automatically lead to greater business impact. Okay, so see, this is the diagram which you have in the textbook. Just like that, you have to explain. At the end, we will talk about traditional BI versus big data. In traditional BI, it's nothing but data warehouses where you used to process data, collect that data in multiple servers, and so many things were there. We'll be comparing this comparison table in the notes as well. In big data is nothing but the latest data. So if you have to talk it about comparison table, so architecture is nothing but central servers, distributed servers. This is only structured data. See, it deals with only structured data, but here it deals with all types of data: structured, unstructured, semi-structured, offline or batch processing, real-time processing, along with the batch also. Paradigm shift. We also tell here the paradigm shift is nothing but earlier the data was converted to core text. So you have process how data was processed, data to code, but now it's shift code to data. So now you can also shift but from code to data. It's just that paradigm shift. Scaling, vertical scaling, upgrading one by one. But here it is horizontal. You can add multiple servers in the middle. Then cost is expensive, it's cheap also. Example to like Oracle, and here we have this Hadoop and Spark, etc. So this completes complete entire chapter 2. I hope I was fast enough in this, and we'll see in the next video where we will complete the module 1 along with chapter 3.